AP, Computer Science A. Unit 5, Writing Classes. Lesson 1, Anatomy of a Class. The objectives of this lesson will be to designate access and visibility constraints to classes, data, constructors, and methods, and to designate private visibility of instance variables to encapsulate the attributes of an object. As we know from Unit 2, classes in general have two primary functions or features. They have variables, also known as fields, and they have behaviors, which we call methods. Now this next one, all of this information is in your notes, but let's go over it, okay? We're going to go over it. We have our public class dog. Our instance variables are the age, the good dog, which is a Boolean, true or false, and their name, which is a string. All of these are private. Notice, private. The default constructor, if we just create a dog, it doesn't have a name, its age is 0, and we assume it's a good dog. We have a number of parameter constructors. We can send it the name, the age, and its disposition, or we could send it just the name and the age and assume it has a good disposition until it proves otherwise. Accessors, mutators, toString, equals, and other methods. We haven't defined those yet. Now, classes represent real-world concepts. Classes are really useful for representing things with multiple data attached to them. For example, if we want to write a program dealing with lots of dogs, we might want to store the dog's name, the age, and such for each dog. To accomplish this goal, we would create a new dog class that will store all relevant information for each dog object we create. When we create a new class, there are a few things to keep in mind. The class name is capitalized. See? Public class dog. Dog is capitalized. The class should go in its own file in the same directory. So we save a class and it's very own file, but it's in the same directory with the program or programs that we're running that are within our project. The file name should match the class name exactly, followed by a .java extension. Okay, so dog.java. Instance variables. Interesting here. At the top of our object creating class, we want to create our instance variables, and we always put them at the top so we can find them easily. This is called a has a relationship. So every dog has a name, has an age, has a good dog quality. When we declare variables, we want to make them private, so other code in other classes can't change their values. We only want the dog class to do that. Constructors. In order to create an object, we need to call a constructor. We need to create. If we don't make a constructor, Java adds a default one for us. It's still a good practice to add the default constructor ourselves, however. In addition to the default constructor, we also want a parameter constructor, where we can create our object with some initial values that are passed into this parameter constructor. Constructors are always public, and they have no return type. It's public, and all a constructor is going to do is set up those instance variables, initialize them all. What else? There are accessors, mutators, toString, equals, and other methods, which we're going to talk about in future lessons. So, going back to our constructors and our class, data encapsulation is a concept that's important to understand. Consider the following code segment, which appears in a class other than dog, in the same project with dog, but a different class. Dog, it's going to be, the variable is doggy, the object variable, and we're going to create a new dog. New dog is going to be named Scrappy. It's going to be 2 years old, and good dog is false. But I don't like that, so I'm going to say doggy, because that's the name of the object, good dog is set to true. I'm going to change it. If good dog was not set to private, this would be a valid request, and it would change the doggy object's good dog variable to true. However, remember that our good dog was set to private, in case you forget. Here it is. Private, Boolean, good dog. Private. Somebody else can't change it on us. So we're going to get an error. Good dog has private access in dog. Can't do that. Even if we wanted to just see an instant variable's value, because it has private access, we still cannot call on it directly. So we declare our dog and we instantiate new dog, having Scrappy as the name, 2 as the age, and false as the good dog quality. And we try to do a system.out.println doggy.name. And again, we're going to get an error. Why? We're not even trying to change it. Because the dog's name is private. Only the dog class can give you the name. You cannot access it in any way, not to print it, not to change it. Java prevents any data stored in private variables from being modified or accessed by any action that takes place in another class. While this may seem a little fussy and extreme, this is actually a very good thing and why we keep our variables private. It prevents someone from accidentally changing a variable's value in some other part of the code while letting us maintain control over validations and how our data is stored in an object. You can't change the dog's name. You can't look at the dog's name unless I give you permission. Okay? Private data. Keep it private. In short, public means something can be used outside of this particular file, and private means it can only be used in this class. These are modifiers. There is a third modifier, protected, but you won't need to know this for the AP exam. So something can be either public, anybody can use it, or private. Only that class can use it. Okay? When designing a class, programmers make decisions about what data to make accessible and modifiable from an external class. If you do not want to see data or modify it after your object is created, you have to make use of accessor and mutator methods. These will be discussed in lesson 3. In general, when writing classes, in Java, it's good to observe the principle of data encapsulation. Data encapsulation means keeping the inner workings of your class hidden from view. You want to make it possible for another class or user to use the class without revealing how everything is done. Keeping instance variables private is one example of data encapsulation. Think about that doggy class. You see someone walking the dog down the street. You don't know the dog's name, the age, or if it's a good dog or not. You go up to the person, to the owner, and you ask that person, what is the dog's name? Once they tell you the name, now you can use it. You might ask if the dog is friendly, or is it a good dog, so you could pet it or not. These are things that the owner of the dog would tell you. That's data encapsulation. Keep that information private. Share it with those that need it or want it in the way that you want it shared. Data encapsulation, methods and variables. This ends lesson 1, unit 5, anatomy of a class.